Hello, today we are going to practice graphing rational functions based on the steps I gave you in class. So here's an example of a rational function, all right? Polynomial in the numerator, polynomial in the denominator. So number one on our list is we need to find any breaks in the domain. And the breaks in the domain are where the domain equals 0, right? So I am going to need to, in this case, factor that denominator. So it looks like this, all right? So if I set that equal to 0, I find out by setting each factor equal to 0. Remember I said factoring never goes away. That I have a break in my domain at 2, and I have a break in my domain at -2. At 2 and at -2, this particular function is undefined, so there will be a break in the domain. How do I know if the break is a vertical asymptote or a hole? Well, remember, it's a vertical asymptote. Let me back up. It's a hole if I can simplify away that part of the denominator. So if I go back to my function, folks, and I notice that I can do this to that function, then the break in the domain associated with that part of the denominator is a hole. If I can't simplify it away, I can't simplify this one away, that means that's a vertical asymptote. All right? Step 2 of our process says, how do we know what the horizontal asymptote is if there is a horizontal asymptote? So we have certain rules, and it has to do with comparing the highest exponent in the numerator to the highest exponent in the denominator. So notice that if I multiplied that numerator together, it would look like this, wouldn't it? And there's my denominator multiplied together. So in this case, the highest exponent in the numerator equals the highest exponent in the denominator. So in that case, our horizontal asymptote is the ratio, so it'll be -3. All right, so I'm going to move to the next page, and we're going to graph what we know so far. We're going to put them on a graph. So we have a hole at 2, a vertical asymptote at -2, and a horizontal asymptote at -3. So we have a horizontal asymptote here. We also have, I'm going to back up, a vertical asymptote at -2. And at 2, I'm just going to say we have some kind of hole. We don't know what the graph looks like, do we? Okay, our third step says let's see if we can find the x-intercepts. Okay, notice that these simplified away. So in order to find the x-intercepts, I'm going to set the numerator equal to 0, and the only part of the numerator left is -3x. So in this case, x equals 0. So I should have an x-intercept at this point. All right. So now I'm going to graph it. So I'm going to my calculator, and remember, we're going to just be very vigilant about parentheses so we don't mess up what this graph should look like. And I'm putting in the original. I'm putting in the original because I need to see where that hole is. Okay? So when I graph this on a good old standard Zoom standard, this is what I get. All right? I can pull some points off this table. Remember, I like to see 3 points to this side of the vertical asymptote, 3 points to this side. Don't use the hole. When you look at your table, you'll notice that at -2, there's an error. And at 2, there's an error, isn't there? Because this is where our hole is. All right, so I have -4. Let's go up one more. So I have -5, -5. Sorry, I'm running out of space. -4, -6, -3, -9. So let's go ahead and graph those roughly, right? 1, 2, 3, 4, 5. So at -5, -5, -4, -6, -3, -9. So something like this, right? This is actually a hyperbola, isn't it? If I go the other direction, I'm going to say at -1, I have 3. At 0, I have 0. We already knew that. At 1, I have -1. And at, let's pick a point, at -4, whoops, sorry. Get rid of that thing. I'll add the point over here. I have it. At 4, I have -2. So let's graph those. -1, I have 3. Okay. At 0, I have 0. At 2 is my error, but at 1, I have -1. So I have this. Notice I'm just going to draw the hole in for the time being. Okay. This is what our graph looks like. I'm going to roughly sketch the graph on the next slide. This is what we figured out. -2, whoops, -3, and at 2 we have a hole. So I'm just drawing it in for now. So how do we write the domain of this graph? Well, I have 2 breaks. At -2 and at 2. So if there are 2 breaks in my domain, there are 3 pieces of my domain. So from -infinity up to -2, not including union, -2 up to 2, not including union, 2 to infinity. For my range, remember, the key to the range is to look at the graph. Sometimes we can cross that horizontal asymptote. In this case, we do not. So that horizontal asymptote, y equals -3, is not crossed, so that's our break in our range. So from -infinity up to -3, not including union, -3 to infinity. So here's an example of us graphing a rational function using the 3 steps we talked about. You need to be able to find the breaks in the domain and show me how you did it. You need to show me a horizontal asymptote if one exists. If not, we have to use a slant. We have to find the slant asymptote. Number 3, you need to find the x-intercepts. Okay? Then the last step is we actually graph it using the calculator and the table off the calculator. All right, so let me know if you have any questions.